So hello everyone, my name is Pritam and welcome to another video. And in this video, we are going to discuss about the operators. This is the second part of the operator chapter. And in the first video, I have discussed about various types of operators like arithmetic, assignment, logical, relatable. There are 9 types of operator which I have talked about. And also some demonstrations on VS Code on different operators I have shown you guys. But I didn't discuss about the bitwise not operator. I told you guys that I would be talking about it later in the upcoming videos. And by mistakenly, I missed the comma operator also. So in this video, the topics which you are going to discuss are: first one is bitwise not operator. The second one is comma operator. The third one is the most important thing, the main part of the second part, main topic, which is type conversion. And the fourth part is also very much important, which is precedence and associativity chart. And also its application. We will be talking about various examples so that you could understand about the chart and its application very well. Okay. So all these things which we are going to discuss, this is going to be obviously a long video. So अगर बैठे हो तो खत्म करके ही उठना, ठीक है, बीच में छोड़ मत देना, बिकॉज अगर तुम छोड़ोगे तो बाद में आके कंप्लीट करने में बहुत टाइम लग जाएगा. यू विल बी वेस्टिंग ए लॉट ऑफ टाइम. सो हैव सम टाइम. ओके, वीडियो का लिंक देखो, उतना घंटा तक बैठ सकते हो तो तभी बैठना, बैठोगे तो खत्म करके उठना, बीच में मत उठ जाना, ठीक है, बिकॉज ऑल द थिंग्स विल बी रिलेटेबल टू ईच अदर. सो डेफिनेटली खत्म करके ही उठना. ओके, लेट्स स्टार्ट. सो B2 नॉट को हम लोग इस तरह से लिखते हैं. दिस इज कॉल्ड टिल सिंबल. ओके, हम लोग उसको इस तरह से लिखते हैं. अगर अभी पकड़ लो, इसका एप्लीकेशन क्या होता है, पकड़ लो, ठीक है. मतलब अगर कोई भी नंबर, फॉर एग्जांपल a इक्वल टू 3, कितना आएगा 3 मतलब 1 1, ठीक है. या फिर पकड़ लो नॉट 3, फॉर एग्जांपल 10. सो व्हाट वुड बी द बाइनरी 1 0 1 0. अब इसके बीट वाइज नॉट करेंगे तो 1 वुड बी कन्वर्टेड 0, मतलब बिट वाइज, ठीक है, सारे बिट्स का नॉट ऑपरेशन होगा, लॉजिकल नॉट ऑपरेशन होगा. अगर बिट 1 हुआ, it would be converted into 0. अगर bit 0 हुआ, it would be converted to 1. That is called bit wise not. मतलब हर एक bit में not operation होगा. Clear? Now, let's take an example and explain it to you guys that how exactly bitwise not works. Okay. So, if I take an example, integer a equal to 3. Okay. Sorry, a equal to 2. Okay. Then what would happen? Obviously 2 means 1 0, but there are various zeros before them. Total 30. If I talk about 32-bit operating system, if it is not, then obviously if it is 64-bit, then obviously the number of zeros would be 62. Clear? Yeah, I'm considering 32-bit operating system. Okay. Now, what will happen? So, a equal to 2, which means 0 0 0 0 dot 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 0 0, then 1 0. Okay, so this is the one. Now, not a. If I write integer b equal to not a, then what would happen? What would be the value of b? We need to understand that. For that, we need to convert it. So 1 1 1 1 dot 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 1 1, then 0 1. Clear? Then 0 1. Now, obviously, this is not going to be the answer because this is a very large number and the not operation of that can't be like that because there are some rules. Because in binary, if the most significant digit, which is called MSD, if the most significant digit is 1, then the decimal equivalent number of that binary number would be negative. Clear? For example, if I write 110, for example, then there are many things. So the most significant bit is 1. That means the number is a negative number. Negative number. Clear? Negative number. So now we have converted, means this is everything has been converted into the not operator, means bitwise not operator has been done. Every zero would be converted to one, and every one has been converted into zero. That's normal, but this is not the answer. The answer would be represented in the two's complement form. Two's complement form. Okay. Now, how to find the two's complement? To find the two's complement, okay, I'm writing it down. To find out the two's complement, we need to calculate one's complement first. Okay. And then we have to add one with the one's complement, and after that we will get the two's complement. So what would be the one's complement of this? Obviously, one's complement would be 0 0 0 0 dot 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 0 0 1 0 again. Okay, and then don't forget the number would be negative. Why? Because these bits are going to be converted. This is for the sign. If it is 1, then the sign is negative. If it is 0, then the sign is positive. Okay. So yeah, we have to add 1. That means 0 0 0 0 dot 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 0 0 1 1. So this is 3, and due to that 1, this is called negative number. So that means minus 3 is the answer. Okay. So if I write integer a equal to 2, then if I write integer b equal to not a, then b would be having the value minus 3. Okay. So let me run the code in VS Code, and after that, you guys would be understanding that everything is correct or not. Okay. So let's go to VS Code. So now here I am in the VS Code, and let's write the code, and after that, let's run it. So hash. So now let's run it and check either it is correct or not. So you can see that the bitwise not of 2 is minus 3. That means, which I have told you guys, is completely fine. So that's it. Now let's talk about the comma operator. Okay. So comma operator pe I do not need to do any kind of explanation. Let's give an example and check it out. Okay. So what we used to write it, a equal to 2, then b equal to 3, and then c equal to 4, for example. And then if I write it is a sum equal to a plus b plus c. Okay. And then if I printf percentage plus sum comma sum. Okay. Obviously, this is going to be executed, and 9 would be the sum. That's fine. But if I want to convert this two line into a single line, then a comma operator is a very crucial thing to be used. Okay. See how. Integer a comma b comma c with the declaration. Now, if I write integer sum equal to a equal to 2, comma b equal to 3, comma c equal to 4, and then comma a plus b plus c. Okay, semicolon, and c, you can see that. So 9 is the sum. Now you can see that how they are going to be executed. Which one is going to be executed first, and which one is going to be executed the last. To find out that, I'm just doing an experiment. Just be with me. Here, if I write printf, so you can see that a equal to percent d backslash and then a equal to 2. Okay. So yeah, initialization would be done and it would be printed out also. So let's check whether everything is correct or not. So here you can see that a equal to 2 has been printed out, b equal to 3 has been printed out, c equal to 4 has been printed out, then 9 equal to sum has been printed out. That means this line is going to be executed first, and after that this one, and after that this one, and after that the last one, okay, will be assigned to the sum. So this is the basic application of comma operator. It won't be used in your day-to-day coding journey, I guess, but it's good to know. No? So that's why I've discussed about all these things. Okay, I hope it is clear to you all. So in this process, we have gone through the procedure to find the 2's complement, which is find the 1's complement and then plus 1. Okay, but there is another process also by which we can find the 2's complement very easily. For example, let's take an example here. For example, we have to find the 2's complement of this. No? So what are that? 1 1 1 1 dot 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 1 1 0 1, I guess. Is it? Yeah, 1 1 0 1. So here all are ones, for example. Okay, so that's why I have put some dots. Okay, so you have to find the 2's complement, and for that you need to search from right to left. If at any point if you find one, then do the reverse of all the binary digits. Like if you found here, or for example, from you are scanning from here to here, if you found one here, so up to 1 everything would be as it is. For example, 0 0 0 1. So up to that everything would be same, but after 1 everything would be complemented. Like if it is 1, then it is 0. If it is 0, if it is be 1. That is what complementary, isn't it? It would be complemented, isn't it? It would be, you can say that it would be changed. Okay. So here, if I find the 2's complement, then what will happen? We have found 1 in the first position. So obviously 1, and then rest of the elements will be reversed. Say for example, 0 would be 1, 1 would be 0, 0, then everything would be 0. That means here it is 3. Yeah. Here it is 3. Obviously, it would be minus 3 because of this 1. Clear? So here you can find the 2's complement very easily. Now let's talk about the type conversion. So now we will talk about type conversion. Now what is type conversion first? Let's talk about that. Okay. For example, until now, what we have learned? Integer a equal to 10, integer b equal to 20. So what are the operations we have done? For example, let's talk about the arithmetic operation. Then we can do a plus b, a minus b, a asterisk b, a divides b, divided by b, then a modulus b. We have talked about all these things. We have talked about many other operators also, but in here, in this example, I am only taking the arithmetic operations. Okay. Now, if I would say that if integer would be a float a equal to 5.5, then what would be the answer of this, and this? Because here this is not applicable, but let's talk about them. Okay, what would be the answer, guys? We don't know. Actually, we know in basic mathematics, we all know that, but in programming, how the computer will compute these calculations, we do not have any idea about that. So to overcome this kind of issues, okay, the type conversion topic is very much needed to be learned. Basically, type conversions are of 2 types: implicit and explicit type conversion. Implicit type conversion and explicit type conversion. Now, in implicit type conversion, there are 2 types. The first one is automatic type conversion, and another one is type conversion in assignments. There are basically 2 types, and we will explore all of them. We will explore this, then this, and then this. Thrice of them are important, and thrice of them has different applications in different situations. Now, first of all, let's talk about automatic type conversion. In automatic type conversion, okay, when 2 types of variable would be engaged in an operation, then what would be the result type, and what would the value of the result? Okay, these are the 2 basic things which you need to understand. Okay, for example, let's take an example like integer a equal to 10, and float b equal to 3.6. So if we do the operation a plus b, then what would be the result and what would be the data type of the result? These are the two basic things you need to understand. Okay. Now, here there is a chart by which we can decide all the things. Okay. So let me write it down, and you also do write them down. I would really recommend that. Okay. So yeah. So now here, this is the chart. Okay, fine. So in this chart, if you take two data types, like for example, float and int, just like this example. Okay, as float is above, okay, above the integer. Float is in upper position, is in the upper position than integer. That's why the result would be stored as float. Okay, clear? And the value also would be added just like that, and the float version. Okay, for example, if I do 10 plus 3.6, then the result would be 10.36. Okay, sorry, I'm really sorry, the result would be 13.6. So the 13.6 would be the result, and the data type would be float. So this is the thing which I wanted to say. This is called automatic type conversion. This automatic type conversion is done by the compiler or the operating system. We can see, yeah, in the upward direction. Now you can ask that why the inventor of computers or the inventor of C language has done such thing. There is a logic. And I am here in this playlist not only discussing about the C programming playlist, all the theories we will be discussing and all the problem solvers we will be discussing. It's not about that. We need to understand the basics. To be a software developer, it's very much important to have a strong root of foundation, isn't it? That's why I'm discussing many things. And I hope that this will be very, very much interesting and beneficial for your whole concept. That's why I'm taking much more longer time to explain. Okay. Yeah. And by the way, if you found these videos like a little bit slow, I would recommend that you could set the in the player option, playback option, set as 1.25 or 1.5. Okay, so that you could watch it in a faster way. Yeah. Now, why this kind of thing it is? So let's check one thing. What is the size of the short int or character? Which is 1. Here it is 2. Here it is 4, 4, 8. And 10, isn't it? So you can understand it that you can see that all the sizes are in the increasing order if we go upwards, isn't it? Now let's take a basic example. When you will be adding two numbers, for example 125 and another one is 25, this is having 3 digits, this is having 2 digits. The result would be coming like this, obviously in the 3 digits. If we take it as 2 digits, okay, then 50 would be the result, for example. Then 1 would be lost. The data is getting lost, isn't it? Means by this concept, I am going to explain one basic thing, okay? For example, you are adding a float and an integer. So float is having the size 4. That means 4 bytes of memory. So obviously 4 byte means 32 bits. And in case of integer, I can say as it is 2 bytes, then obviously there will be 16 bits, isn't it? It is about 32 bit, then it is about 16 bit. Clear? So obviously bit means either 0 or 1 in computer. Means in computer we only store the data as binary, right? Either it is 1 or it is 0. So obviously there would be 1 or 0. There are 32 number of ones and zeros, and here it would be 16 numbers of ones and zeros. So if we add the 16 bit of data and 32 bit of data, okay, and if you store them in 16 bit of memory size, then obviously the data would be lost. this part will not be stored in this position, isn't it? So data would be lost. That's why we have to store the data by this format, which is bigger, which size is bigger. Okay, we have to store the data in this data type. That's why the result is getting stored as float here. If you take long double and float, then long double would be in long double. If it is double or float, then it would the result would be stored in double. If it is about a long int and float, then obviously it would be in float. If it is long int and int, then it would be stored in long int. So in this way, automatic type conversion actually works. So what does it mean? If we add something, okay, if you want to add something and if you want to store in by default it will be stored in float. So it does it mean that we can't store it as character, we can't store it as integer? Or what if we write integer x equal to, for example, 97, okay, and if I write character ch equal to x, then what would be stored in character here? So this kind of situations also we have to face, and to overcome this we need actually type conversion in assignments. Type conversion in assignments. Okay, so what is type conversion in assignment? It's here in its name itself. Type conversion using the assignment operator. This is the assignment operator. This is an assignment operator, isn't it? So type conversion using assignment operator. Now how it would be happening? For that we need to understand that. One thing, yeah. So let me give some examples and you will, I guess you will have an idea. For example, if I write float x equal to 5.6. Now if I write integer y equal to x, then the integer part of y would be stored into, sorry, x would be stored into y. That means y would be having only 5. Now if I write integer z equal to, sorry, not integer, if I write integer float z equal to y, then z would be having 5.0. This 5 would be stored into float and the result would be 5.0. That's it. Yeah, so this is called type conversion assignments. Now if I talk about this example, okay, if I talk about this example, then what would happen? So character c equal to x, where is x equal to 97, then c would be having the value, okay, small a. So now how it is small a? This is called ASCII values. Okay, and we will talk about it in later in upcoming videos. Right now, this is not the correct time to discuss about this thing, but we will definitely talk about ASCII values soon. Okay, but you can understand by one line that every character in your keyboard is having an equivalent in integer value, which is called ASCII value. ASCII value means American Standard Code of Information Interchange. Okay, so it's a standard where the code of information interchange. That means if you put character, the equivalent would be in integer for the computer, because computer doesn't understand characters, isn't it? So it understands only value. So the character would be break into some digits which will represent a binary number, obviously, which will be calculated as a decimal number for us. Obviously, we will be calculating in decimal numbers, but for computer, it will be breaking into some binary codes. Yeah. So that is called the ASCII value. Just for now, you need to understand that there's just an equivalent integer value for this characters by default stored in the computer. That's it. We will talk about the ASCII value later in some upcoming videos. I don't know where, but I will definitely talk about it when the right time will come. According to the playlist, we will be moving on. Okay. Now you do not need all these things. Okay. So I'm writing down some ASCII values. You need to remember them. Okay. So if it is capital A to capital Z, it would be like 65 to 90. That means capital is 65, capital B is 66, capital C is 67. Small a to small z, if it is like 97 to 122. And if it is 0 to 9, okay, 0 is also a character. because computer doesn't understand a decimal number also, right? So when you would be pressing 9876, so how they will understand that what exactly it is, isn't it? That's why 0 to 9 is also having some ASCII value, which is 48 to 57. Okay, you need to remember them. Like for example, alpha, it is 2 to 4. Okay, beta, it is 2 to 5. Then if I talk about gamma, it is 2 to 6, just like that. Okay, the space bar. Okay, the space. Okay, space would be having the ASCII value of 32, I guess. Okay, so just like this, you just need to know these things mainly. Okay, so these are called ASCII values also. So to find out the ASCII values also, the way this is an application of type conversion. The type conversion assignments would be applied here. Okay, now let's talk about another example. For example, if I want to take for example, if you want to extract, okay, the integer part from a float, then obviously this is the golden opportunity to use the to use the assignment operator here, which will be type conversion in assignments. Correct. So this is all about the implicit type conversion. Okay, I hope you are understanding, but there are some disadvantages of implicit type conversions. There are some scenarios where implicit type conversions can't fulfill your requirement. So at that time, okay, at that time, the explicit type conversion comes. Okay, so the basic syntax of explicit type conversion is, for example, if any variable is x, which is the type of int, and you want to make it as float, then what you have to do? You just have to write float within parentheses and then write x. And if you write float y equal to like this, then the float value of x would be stored into y. For example, if x is equal to 5, then if I write float y equal to float of x, then y would be having the value 5.0. Okay, so let's take an example and try to understand the disadvantage, means that kind of scenario also where all these things will be happening. For example, if I write integer x equal to 20, okay, and y equal to 3, and then if I write float z equal to x divided by y, okay, then what will happen? Obviously, x divided by y, this is integer division. That means 20 divided by 3, which means 6. And then 6 will be converted into float. That means that will have the value 6.0. But in real life scenario, we need the data, which is 6.667, the real data, the real division. Okay, so for this kind of scenarios, we can see that automatic type conversion and type conversion in assignments are unable to get the actual result. In this scenario, we need explicit type conversion, or also we can call it as type casting. This is also another name. Okay, type casting. Okay, now what we have to do? We have to write like this: float z equal to float of x whole divided by y. So here what will happen, that float of x, okay, float x will, that means the x will be converted into float. That means it would be like 20.0 divided by y is 3. 20.0 divided by 3, which means obviously a float is getting divided by an integer. Then the data, the output would be in float automatically, which is 6 point, obviously 667, for example. And this float is getting converted in, this float would be stored in z. Now, if I write here only integer, then z will have the value 6, as I have written float. That's why the z value would be 6.667. And here why it was 6, because it is into integer division by default, isn't it? That's why we need to convert it as a float, 20 or 3, any one of it doesn't matter, but everything would be same. Okay, so yeah, that's the explicit type conversion. And I'm not writing any code in VS Code because these things there is nothing to show. You need to understand the concepts. Actually, these are the basics theory which you need to understand. Okay, now let's talk about a scenario. For example, if I write, okay, A equal to 2, B equal to 3, and C equal to, for example, 5. Okay. Now, if I write A plus B asterisk C, okay, this is the expression, then what would be the answer? The answer would be two types, obviously. Either it is A plus B whole asterisk C, or it is A plus B asterisk C. Okay, any of two, because obviously there are two operators. Which one would be evaluated first? That's a matter of conflict, na? That's a matter of confusion actually. So to avoid this kind of ambiguity, you need to understand that which one should be evaluated first. Okay, and you need to see this also. A plus B asterisk C, which means 2 plus 3 in, that means 5 into 5 is 25, whereas here it is 5 into 3 is 15, and then 15 plus 2 is 17. Obviously, 2 plus 5 into 5, 15, 17. So there are two different outputs. So which one would be correct? That's the main thing we need to understand. And to guess the correct output, you need to know that which operator would be evaluated first, isn't it? So for that, we need to know about the precedence and associativity chart. Okay. Precedence means which one would be evaluated first. Okay. And associativity means if there are two same operators, same type operator, same level operator, same precedence operator, then which one would be evaluated first? We will be deciding it by associativity. Okay. So there is a chart, and let me write it down, and after that we will obviously talk about it. So here this is the chart. Okay, so here in the second column, you can see the operators line by line. All the operators are written here. Okay, and in the these are operators obviously, and in the last column there are associativities. Okay, left to right, right to left, and all. So first of all, let's talk about that. What is the function of this chart? Okay, the function of this chart is, you can see in the second row. Okay, there are various layers, various rows. Okay, if any operator would be picked up from the upper one and any operator would be there from the lower one, then the upper operator would have the higher precedence. That means the higher position operator would be evaluated first, and after that the lower one. Now what if, like for example, in this example I've shown you guys, here there is a plus operator, there is an asterisk operator. So as we can see that here this is asterisk operator and this is plus operator, so this, it is having higher precedence. Then obviously this will be the correct one, this is not going to be the correct one. Okay, so in this way the output is 17 for sure. Okay, you can run it on VS Code. I'm not showing you guys. You can run by your own, and if any kind of doubt is there, any kind of false answer or anything, any issues is there, then let me know in the comment below. Okay, so accordingly we can check. Now what if all the operators are from same same precedence? For example, let's take an example like this. For example, A asterisk B divided by C. Now what will happen? Okay, the asterisk and divide. By the way, if I have written asterisk before or divide after asterisk, it doesn't mean that asterisk is having means multiplication is having higher precedence than division. It's not like that. I just written over here. You can rearrange the arrangement in the same layer. It doesn't matter. Okay, so how would you evaluate this one? Okay, here the associativity comes. Associativity means we will be scanning from right to left or left to right. That is the thing we need to know. So here it is left to right. Okay, that means we have to scan from left side to right side, and if we get if we get anyone before, means मतलब पहले अगर स्कैन करोगे तो ये वाला अगर पहले मिलेगा तो this would be evaluated first, and the division operator would be evaluated later. Okay, that means this is number one and this is number two, in this way. We will have a lot of examples. Don't worry, you will get to know all the things very well. Okay. So this is all about, but now there is a problem. The problem is how to remember. There is a big chart. It is how to remember. Okay, for that I am showing you a very shortcut way. I don't think that you will find this technique anywhere on the internet. I guess that would be much more beneficiary if you could remember that technique rather than remembering all the things by your own. Okay, so here these are the parenthesis operator. This is called period, and this is called arrow operator. These are the operators we will be talking about them in the structure chapter. Okay, so I'm putting a cross here, and these are unary operators: plus, unary minus. Okay, and then unary plus, unary minus means increment and decrement operator. Then logical not, bitwise not. Okay, this asterisk. This is called indirection operator, and we will be talking about it in the pointer chapter. Then address of operator. This is also in the pointer chapter, but you have used it in the scanf function, scanf percent d ampersand n. So this ampersand is the address of operator. Then data type. Okay, we have talked about it here already in the explicit type conversion. Okay, data type, isn't it? This is data type. So this is the one data type, and then size of also we have talked about in the part 1 of the video. Okay, so as it is unary operator, I am writing here an u. Okay, u for unary. Clear? U for unary. Now let's talk about this one. These are called arithmetic operators. So here I am writing A. These are shifting operators. These are comparison operators. These are Boolean operators. These are logical operator. And we are having a blank here. And this is another A, and this is another C. So let me write down all the full forms, which is arithmetic, shifting, comparison, then bitwise or Boolean, you can say. This is logical. This is assignment. And here it is comma. Okay. So you can see that I have written everything here, and we are going to summarize the thing now. Okay. So what we can see, U A S C B L A C. That means U A S C B L A C, and here it is a cross. So U means unary, arithmetic, shifting, comparison. So why I am written comparison here? Because these are relational operator, but if I put R, then the shortcut form won't be that much perfect. Okay. So to make you guys understood, I have used comparison here. And here it is bitwise, it is logical, and this arrow means obviously there is a ternary operator called conditional operator. Okay. And here it is arithmetic, and here it is comma. So there are two A's. The first one would be arithmetic, the other one is assignment. You need to remember this. And cross means, you know, parenthesis, a dot and period, and that's it. So in this way, there is a shorter way we can remember. You ask black. Okay. You ask black, BLSC black. Okay. So yeah, that's it. That's the chart. And now let's talk about some examples. So here there is the first question: A equal to 8, B equal to 4, C equal to 2, D equal to 1, E equal to 5, and F equal to 20. And now here this is the expression which you need to evaluate, and you have to say the answer. Okay. Now there are various operators, as we can see, that plus, minus, plus, asterisk, modulus, F, plus, and division. So all the operators are of arithmetic A, under A. Na? So you ask black. So obviously A is in obviously left to right. So another thing is right to left is only two, like unary and assignment. Only these two are right to left associativities. Otherwise, everything is left to right associativity. So be blind and use the left to right associativity. If by the way, among these, this modulus and the division operation and the multiplication operation is having higher precedence. And also these brackets are there, parentheses, which are the highest precedence. That means we need to understand that this is number 1, then here it is number 2, and then here it is number 3, number 4, number 5, number 6, and number 7. Okay, now let's evaluate. So C plus D would be I guess 3, and 3 into 3 would be I guess 9. Okay, then 9 modulus 5, which is equal to 4. Okay, and now 5 is A plus B, and 8 plus 4 is always equal to 12. Then 12 minus 4, which is equal to 8. Okay, and then another one is, okay, after 3 there would be 4 also. 4 is F divided by 9. F is 20, 20 divided by 9. Now 9 into 2, 9 into 2 is 18. That means 2. Okay, so 4 also, 3, 4, 5 also done, 6 also done. Then 7 would be then 8 plus 2, which is equal to 10. Okay, then 10 would be the answer. Okay, you can check on VS Code also, so don't worry, you can check it out. So in this way you need to evaluate the things. I hope it is clear. Let's talk about the other examples, and I hope after all the examples your doubts will be clear. Okay, so here this is another question, and we need to write them separately so that we could bracket them out. Okay, so A modulus 6 minus B divided by 2 plus C asterisk D minus 5. Okay, we need to bracket them. Okay, so in this bracket, obviously C plus D would be evaluated first, and then here it is 2, and then obviously left to right, that means this would be 3, this would be 4, and then this would be 5. Then obviously this would be 6, and this would be 7. Okay, now let's okay, so 1 and 1 because C into D. C into D means 18. 18 minus 5 would be 13. Okay, and then A modulus 6, 17, 16 to 12, 5. Then 5 divided by 2 would be 2. Then 5 minus 2, okay, 4, then 5 would be, okay, this one. Then 13 divided by E, that means 5, that means it would be 2. Okay, and 5 minus 2 would be 3, and 3 plus 2 would be 5. Then 5 would be the answer. Okay, so in this way we can solve. Now let's take another example. So here this is another example, and now let's write it here. So A asterisk B minus C divided by D less than E plus F. Now obviously asterisk would be the first one, then divide would be the second one, and then here there is a relational operator also, by the way. So we need to be very careful. What was the formula? U A S C B L A C, isn't it? So here A is arithmetic operator, C is comparison operator. So after all the arithmetic operators, the comparison operator would be evaluated. So this is done, then there would be, this would be number 3, okay, and this would be number 4, and then this would be number 5. Okay, so now let's evaluate. Okay, A asterisk B. A asterisk B means 4 into 5, which is 20, and C divided by D. So 6 divided by 3, which is obviously 2. Now this is number 3. Then 20 minus 2. That means obviously it is 18. Now here this is number 4, E plus F. E means 5, F means 10. That means it is 15. Now we have the number 5, okay, which is 18 less than 15. This is the one, na? 18, then less than, and then 15. Now 18 less than 15 is true or false? Obviously false. 18 is greater than 15, not less than 15. That means it will be returning 0. We have discussed, na, in the relational operator, the relational operator would return 0 when it is false, when the relation is false, and would return 1 when the relation is true. So here the relation is false, that's why it will be returning 0, and this is the output. Okay, clear? I hope it is clear. We have evaluated, and then the relational operator has been working, and then it is true false, that's why it is 0. Okay, so this is the third problem. Now let's talk about the another one, which is fourth problem. So here this is the fourth problem, and here there are very so much variables, and it's a big expression, so it is going to take some time, obviously. So let's write it down first. So okay, comparison operator, arithmetic operator, these are the thing. So here this is the first, this is the second, this is the third, this is the fourth, this is the fifth, and this is the sixth, and this is the 7, and here this is the 8. Okay, so now obviously okay, so we need to evaluate them. Okay, so 1, C divided by D. C divided by D. C is 8, D is 3. So 3 into 2 is 6. That means it's 2. Then number 2, E divided by F. E is 65, F is 10. So it would be 6, obviously. Then number 3, H modulus K. Okay, so H is 5, K is 2. 5 modulus 2 obviously would be 1. Okay, now number 4, A minus B. A minus B is 8 minus 5, which is equal to 3. Number 5 is, okay, 5 plus 2, which is 3 plus 2, which is equal to 5. Then number 6 here, 6 minus G ka value is like 2, so it is 4. Okay, then 7, okay, obviously 4 plus 1 is 5. Then 8 is 5, this 5, and this 5, and this equal operator, which means obviously 1, because it's true. That's it. Okay, so in this way we can evaluate, and I am going to show you the last example, and after that we will be ending up by the video, I guess. So here this is another example, and here we are going to do the same approach, obviously. Yeah, so A minus B, or A minus B asterisk C, okay, plus D and E minus F modulus 3. Here there are two approaches. First of all, let's talk about the conventional method, which I have shown you guys, and after that I will talk about a tricky thing which I have discussed earlier also, but this is the application also. Once that theory would be applied here as well. Okay, so let's stick into it, and this is the last problem, by the way, so don't be hesitated, and yeah, don't, just have some patience. Okay, so yeah, A minus B, that means, okay, so here this logical OR, so U ASC BLAC, isn't it? So A and B. So B में मतलब सॉरी इट्स लॉजिकल ऑपरेटर, सॉरी लॉजिकल में मतलब पहले आता है एंड, उसके बाद आता है और, वी हैव सीन इन द चार्ट. ओके, so this and would be evaluated first and this or would be evaluated second. And so yeah, let's check then. Okay, the brackets, obviously this is 1 in bracket, and this is asterisk, so it is 1, and this is 2, and then this is 3. Okay, and then this is 4, and then here it is 5, here it is 6, and then here it is 7, and then here it is 8. Okay, so yeah, now number 1 B asterisk C. So 3 into 2 is 6, and then A minus 6, that means the number 2 after that it would be 8 minus 6, which is 2. Okay, and here it is number 3. Number 3 is F asterisk 3, then 11 asterisk 3, which is 3 into 3 is 9, that means 2. Okay, and then 4A minus B. Okay, 8 minus 3, which is 5, and then there would be 5. 5 means 2 plus D, that means 5, and then 6 E minus 2, then it is 0. Okay, so now you can see that 5 or 5 and 0. So it is going to evaluate it first, and it is going to evaluate it secondly. Okay, so 5 and 0, which is obviously 0, and 5 or 0, which is obviously 1. So the output is 1. Clear? But there is a catch. So here A minus B, which is 5, that means 5 is obviously 5 is a true value. So true value, that means we do not need to check to the other one, and directly we can say that the output is 1. So you can see that by this technique you can avoid a lot of calculations, isn't it? So that's it. That's the way to solve this kind of problems. And this is all about precedence and associativity chart. I hope you have understood it. If you haven't understood anything, or I would recommend to watch the video once again. Okay, watch the video once again, and if any kind of doubt is there, guys, there is a link to my Telegram channel. There you can comment out any kind of doubt, and I will definitely try to answer them in the doubt clearing session. If many more doubts would be coming up frequently, then I would definitely make a video on doubt clearing session. So don't worry, I will make it live also. I will announce it. If you want me, I will make a live also on YouTube about the doubt clearing session if you want me. Okay, so yeah, that's it. And if you really like the video, then obviously like कर देना यार, and subscribe कर देना, on bell icon भी press कर देना, क्योंकि यार भाई को बहुत मदद मिलती है, बहुत मोटिवेशन भी मिलता है बहुत सारी वीडियोस बनाने के लिए. आई रियली नीड मोटिवेशंस एंड योर सपोर्ट एज वेल. सो डेफिनेटली लाइक हिट द सब्सक्राइब बटन, एंड या शेयर कर देना वीडियो दोस्तों के साथ, उनको भी पता चले कि मतलब कैसी कैसी चीजें पढ़ाई जा रही है यहाँ पे. ठीक है, सो दैट्स इट. या दिस मच फॉर टुडे, एंड सी यू ऑन द नेक्स्ट वीडियो.